Good evening, children. I hope everyone are doing fine. Let us begin with the new chapter, that is chapter number 3, Atoms and Molecules. Okay. So before getting into the lesson, so you people have already studied about what is atoms, what are molecules, and what are the size of these atoms. So let us have a brief introduction to the chapter, and we shall recall all the basic things, and we shall see what is atom, what are its size, and how it is measured, and whether it has a mass. So we will study all this in today's class. So let us begin. So, coming to the discovery, okay. So, ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. So, we know, children, what is matter. So, the thing which occupies space and as a mass is said to be matter. And these ancient Indians and also Greek philosophers, they were always wondering so about this matter, so how it is formed and how it is obtained. So they were very curious about that. Okay. And the idea of divisibility of matter was considered long back in India. Okay. So the idea of dividing this matter, it was considered long back in India around 500 BC itself. Okay. So one among that philosopher, Indian philosopher, was Maharishi Kannad. So he was a philosopher, Indian philosopher. He postulated that if we go on dividing matter, that is padarth. Okay, so if we matter is otherwise called as padarth. If we go on dividing this matter, we shall get a smaller and smaller particles. Okay, so this was discovered by Maharishi Kannad. Okay, so ultimately, a time will come when we shall come across the smallest particles beyond which further division will not be possible. Okay, so we are taking one matter, for example, we are taking a chalk piece. Imagine it is a matter, solid matter. If we keep on dividing that into small particles, so what happens at last? So fully it will be divided and further division won't be possible. It will be like a powder, right? And he named these particles as Parmanu. So it is a word that he used in during his time. Okay. So he named these particles as Parmanu. So another Indian philosopher by name Pakuda Katya, Katyayama, so he was a person, he was another Indian philosopher. He elaborated this doctrine and said that these particles normally exist in a combined form. So he said that these particles, so the fine particles, are exist in the combined form, which gives us various forms of matter. Okay, around the same era, so same period, ancient Greek philosophers like Democritus and Leucippus suggested that, so here you can see them in the picture. So these two, they said that they suggested that if we go on dividing a matter, a stage will come. Okay, so divide ಮಾಡ್ತಾ ಹೋದ್ರೆ ಒಂದು stage ಬರುತ್ತೆ, so where the particles obtained cannot be divided further. Okay, Democritus called these indivisible particles atoms, that is indivisible. So mean indivisible particles atoms, he gave that name. So that meaning is indivisible, further it can't be divided. Okay, so all this was based on the philosophical consideration and not much experimental work. So they never did any experiment on this, but it was just like a philosophical consideration, ಅವರು ಹಾಗೇನೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು. Okay, and this all experimental work was done in 18th century. Okay, so by the end of 18th century, scientists recognized the difference between elements, compounds, and naturally became interested in finding out how and why elements combine and what happens when they combine. So 18th century at the end of 18th century ಆದ್ಮೇಲೆ scientists started discovering, so what is elements, what is compounds, and what happens if one element combine with another, what happens further. So all this was discovered at the end of 18th century with the experiment. Okay, so there comes Antony L. Lavoisier. laid the foundation of chemical sciences by establishing two important law of chemical combination. Okay, he was a person, Antony L. Lavoisier. So he gave a foundation of chemical sciences. Chemical science ಗೆ ಒಂದು ಫೌಂಡೇಶನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದ ಆಂಟೋನಿ ಲ್ಯಾವಿಸಿಯರ್. ಓಕೆ, ಸೊ ಈ ಎಸ್ಟಾಬ್ಲಿಷ್ಡ್ ಟೂ ಇಂಪಾರ್ಟೆಂಟ್ ಲಾಸ್ of chemical combination. So we shall see that two laws of chemical combination in the next class. So before that we shall see what is atom and how big are these atoms, and what are the modern day symbols of atoms of different elements. So all this we shall see, and also atomic mass. Okay, and we shall see few tables to understand symbols of elements and also atomic masses of few elements. So children, before going to atoms, so we see tall buildings, and we also come across this ant hill, right? So there's a mistake, I've gave only hand, it is ant hill. So we know that bricks are the major thing to build a building, right? So big bricks are the building block of a building, right? And even a small sand grain is a building block of a ant hill, right? So to build a ant hill, so what these ants do, they get the sand grain and they keep on building that. So we can say that a small sand grain is a building block of an ant hill, right? So here, so why we are taking building blocks, because they are any matter. So take for example any matter you take, so that matter is made up of an small particles known as atom. Okay, so coming to atoms, so we have observed many buildings, so many walls of the rooms, and also many matters we studied in the previous chapter, and handle for the example, right? And all these are made up of small particles called as atom. So atoms are the building blocks of all kind of matters, and they are very small, and they're so negligible, they can't be seen. Even with well defined microscopes also, these are not visible. Only the surface of group of atoms can be seen, like silicon you can see in the example. In another example you can see chalk piece is a matter that is made up of small particles. Okay, so only in well magnified microscope only a surface can be seen. Apart from that, individual atoms cannot be seen at all, it is that very small. Okay, and how big are these atoms? So atoms are very small, they are smaller than anything that we can imagine or compare with. Okay, more than millions of atoms when stacked would make a layer barely as thick as a sheet of paper. Okay, so I'll tell you. So atomic size of these atoms are nanometers. So nanometers is nothing but 1 mm, that is equal to 10 to the power minus 9 m. Okay, that is 1 meter is equals to 10 to the power 9 nanometer. Okay, so it is very small, that small. And image of surface of silicon you saw right now, only a surface can be seen. Okay, so John Dalton was a person to give this atomic theory. So according to him, every atom has a characteristic mass. So he said about the atomic size and all. Okay, so John Dalton was born in a poor weaver's family in the year 1766 in England. Okay, and he began his career as a teacher at the age of 12. So 7 years later, he became a school principal. In 1793, Dalton left from Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. Okay, in 1808, he presented his atomic theory, which was a turning point in the study of matter. So we shall see his theory in the further classes. So let's see about this atoms. Okay, so according to John Dalton, so every atom has a characteristics mass. That means atom has a mass. Okay, so this was given by John Dalton. Atomic mass andre atom gu saha weight ide. It is also having some mass. It has some weight. Okay, this concept was given by John Dalton. Okay, coming to atomic mass unit. Okay, atomic mass unit, so shortly it is called as 1 AMU, that is 1 by 12th, sorry, it is mentioned as 16, 1 by 12th into mass of an oxygen atom. So why oxygen is considered? Oxygen is considered because of two reasons. Oxygen reacted with many large number of elements, okay, so and that is going to form a compound, and this atomic mass unit gave masses of most of the elements as a whole numbers. So in 1961, carbon 12 was chosen as a standard reference for measuring atomic masses. Okay, so I'll tell you, if you consider one watermelon, so we will make it into 12 pieces. Okay, and that one piece is said to be one 1/12 of the whole. Okay, so that is the comparison you can make out. So 1 AMU is 1 half into mass of an atom of carbon 12. So 1 atomic mass unit is a mass unit equal to exactly 1/12. So the mass of one atom of carbon 12. Okay, so according to IUPAC, IUPAC is an international union of pure and applied chemistry, where the rules and rules is made regarding chemistry. Okay, so this is a IUPAC is an international union of pure and applied chemistry. Okay, where exactly it deals with the many rules and regulations in chemistry. Okay, and now it has been changed. One AMU, that is atomic mass unit, has been changed, and now it is written as, when we were studying it was AMU, but now it has changed to U, that is unified mass. Okay, you should remember this. For example, take a helium. So helium na naವೇನು ಮಾಡ್ತೀವಿ, one we will consider a weighing machine and we will place helium at one place. Okay, and as I said, carbon 12 is taken as a main thing. So carbon 12, we know that it has a 12 units, right? So we are weighing helium, it is very weight, and it is and we need to balance, right? So what we are doing, one, we have cut this carbon into 12 pieces, imagine like that. So 12 units. Okay, so we are taking each unit of carbon. So one unit we are taking and we are checking the weight of helium. No, it is not balanced. Again we are taking one more unit. No, it is not balanced. Again one more unit, it is not balanced. Again one more unit, totally 4 units we are taking. Okay, so later on it will get balanced. That means helium has 4 atomic mass unit. Okay, so coming to the table, you can go to you can check with the page number 34. You have symbols for some elements. Okay, that is aluminum, argon, barium, boron, bromine, calcium, carbon, chlorine, cobalt, copper, fluorine, gold, hydrogen, iodine, iron, lead, magnesium, neon, nitrogen, oxygen, potassium, silicon, silver, sodium, sulfur, uranium, zinc. So this table gives you the symbol for many elements. So it is very important for you to practice, children. Okay, so coming to the other table, atomic masses of few elements: hydrogen, carbon, nitrogen, oxygen, sodium, magnesium, sulfur, chlorine, calcium. So what is the atomic mass? That is, what is the unified mass of these elements? So that means carbon is taking as a main thing. Okay, and they are measuring the atomic mass unit for each elements, like how I gave the example of helium. Okay, same way. So children, this was the basic concept, and also we saw about atomic size and atomic mass unit, and also we studied few tables which shows the symbols for elements, and also atomic mass unit of few elements. Just go through it. So in next class we shall deal with the laws of chemical combination and laws of conservation of mass, and also law of constant proportions. Okay, see you all in the next class. So I'll be sending the worksheet. Do solve it and have a good day.